Hey, so, throw your name on here. It is second hour currently. Alright, I hope we can fill this in now. A system of equations is a collection of two or more equations. So instead of solving one equation at a time, we're solving two. They have to function together, system together. Okay, the solution to a system of equations is the point that makes both equations true. Help me remember when we get to our examples on the back here, to show you how to check again. These ones are even easier to check than the ones yesterday were. Okay, we have the exact same list of steps that we had yesterday, but this time step number 1 isn't crossed out because today we are going to have to do step number 1. So if you want to put a little note to yourself, this is the new part of today. The only difference between today and yesterday is at the beginning of the problem, we have to do step number 1. We are responsible for solving one of our equations for x or y. Hence why I did that quick right. Because we need that in order to be able to substitute it in. So, first thing that we're going to do, I'm going to skip over to steps 2 through 6. They're the exact same as yesterday. We'll talk about them when we get to the back of our assignment, or the back of our note sheet. First thing that we are going to do is practice solving for x or y. So down here, we've got 4 just single equations. These aren't systems, they're just equations. We are going to practice solving for x or y. We did this back in 1.8, but in 1.8, I told you what to solve for. Today, you're going to have to decide what to solve for. And the best thing to do is always solve for the thing that is closest to being by itself already. So let me zoom into these guys. This top left one here, x minus 2y equals 1. We are deciding whether we are going to solve for x or for y. What is closer to being by itself, x or y? X, because that y has a negative 2 with it. So the x, all we have to do is get rid of the minus 2y. To get the y by itself, we would have to get rid of the x and the negative 2. So put a little note to yourself that we are going to solve for x. And then we are going to go ahead and do that. How we do that, we want to get rid of the minus 2y. So we're going to add 2y to both sides. We have x on the left side of our equation. And on the right side of our equation, we have 1 plus 2y. That is not 3y because the 1 doesn't have a y with it. So we cannot combine like terms there because those are not like terms. One is a constant, one has a variable. So we're just going to leave it as x equals 1 plus 2y. You could put 2y plus 1. It really doesn't matter. You're going to end up plugging it into something anyway. Now we have an equation that's solved for x, so we would be able to plug that in to another equation for x. Okay, the next one, we've got negative 3x plus y equals 4. What's closer to being by itself? Y. So we want to move the x, leave the y. So we're going to add 3x to both sides. We'll do y equals, we can write down 3x plus 4 or 4 plus 3x. I'm just going to leave it in that order. Doesn't really matter. Let's put a note to ourselves that we solved for y. Not add. Okay, bottom row. Negative x plus y equals negative 3. Neither of them have a number with them. Which one's going to be easier to solve for, though? Y. Why? Because the x is negative, y is positive. So it's going to be easier to solve for y. I agree. So we can add x to both sides. And have y equals negative 3 plus x. Okay, last one. What's easiest to solve for? Yeah, neither of them have a constant, or sorry, a coefficient. Neither of them have a coefficient other than 1. They're both positive, so they are the exact same amount of work to solve for. So let's do both, just so you can see it in your notes. Solve for x, solve for y. And write down x plus y equals 17. X plus y equals 17. I'm just rewriting it twice, so I have it twice for myself. If I were to solve for x, I would need to subtract away the y. I would get x equals 17 minus y. Off the screen there. If I were to solve for y, I would need to subtract away the x. Put your calculators down. We're not using calculators for anything right now. And I would get y equals 17 minus x. So either way, it ends up being exactly one step. And the steps are the exact same amount of difficulty. There are times on your assignment today where it would be just as easy to solve for one variable as another. There's a time when there's 3 different variables, like an x in one equation and then the x or y in the other equation. So there's 3 different options of how you could do the problem. I spent forever, look at this, on here. Oh, there it is. I spent forever doing this problem 3 times. Oh, there's the answer. So that I had all 3 on my answer key. So there is a large chance that you will not do the problem direct or exactly the same as the person next to you, and you will still get the same answer, and you guys both did something completely correct. There is a chance that will happen because there's multiple ways to get to the same solution that are just as easy as each other. Okay, any questions right now? Okay, we are going to pause notes right now. Leave your note sheet on your desk. I'm going to pause. Hello again, video. Okay, so you guys all just practiced solving for x or y. On those first 2 sets, we told you what to solve for. I think most of our groups made it to the 3rd set where you had to pick what to solve for. So in your problems today, we are not going to tell you what to solve for. You have to pick. But for most of them, there will always be at least, or for all of them, there will always be at least one variable that's pretty easy to solve for. The reason why is week after next week, after Thanksgiving break, we are going to learn a 3rd method of how to solve systems. When we learn that 3rd method, that's what we would use if there was no variable that was easy to solve for, okay? So, in this first system here, which of these variables out of all 4, x, y, x, y, which is closest to being by itself? Which y? The top one. So, put a little note to yourself that you are going to solve for y in number 1. So we're solving for y in the first equation, which I'm calling number 1. Then we are going to go ahead and do that. So I'm going to take that equation, 4x plus y equals -3. And I am going to solve for y. So I'm going to subtract 4x from both sides. Now I'm going to get y equals -3 minus 4x. So that right there is the new part of today. That is your new step 1, is solve one equation for x or y. Now, we are ready to go back to our old steps 2 and 3. So step 2 is to substitute that equation into the other equation. Step 3 is to solve that equation for the first variable. So we have to remember that we just rearranged that top equation. If you would like to gently cross it out, you can. Don't scribble all the way through it because you want to be able to see that see what it is so you can refer back to it later. Now we can take this negative 3 minus 4x. So we know that y equals negative 3 minus 4x. We can plug it into our other equation. If we're going to plug it into our other equation, where do we plug it in? For y, because it is y equals. So we're going to plug it in for this y right here. Okay, so my next step, I've got 2x plus 2. Instead of that y, I'm plugging in negative 3 minus 4x. I'm substituting that in. That's equal to negative 12. I'm writing too big. I'm going to run out of space. You heard it here first. I'm going to run out of space. All right. Any questions right now? So that is step 2, which is exactly what we did yesterday. We substituted that in for y. From there, we can distribute, combine like terms, solve. So distribute 2 to negative 3. I can rewrite my 2x. 2 times negative 3 is negative 6. 2 times negative 4x is negative 8x equals negative 12. Then we can combine like terms. 2x minus 8x is negative 6x. Minus 6 equals negative 12. Okay, and then we're going to add 6 to both sides. We'll have negative 6x equals negative 12 plus 6 is negative 6. And then we'll finish dividing. We'll finish solving by dividing. Divide both sides by negative 6. X equals positive 1. Wait, I guess I'm not going to run out of space. I can use this space over here. So I now know that x equals positive 1. I still need to solve for y. Any questions before I go back and do that? You guys have a question? Okay, stop talking, please. Okay, so we are ready then for steps 4 and 5, which is to substitute your solution into the other equation and solve that equation for the second variable. So we are going to come down here. We're going to use this equation that we had, the y equals, because we need to solve for y. So I'm going to use that y equals equation we made ourselves. Y equals negative 3 minus 4x. And we're plugging in this 1 for that x. So it's going to be y equals negative 3 minus 4 times 1. Okay. Negative 4 times 1 is negative 4. So this is just going to be negative 3 minus 4. And then negative 3 minus 4 is negative 7. So y equals negative 7. Okay, last thing that we need to do, write our answer as an ordered pair. X comes first, so it's going to be 1, negative 7. I told you I was going to run out of space, and I barely fit it in. Okay, any questions right now? Okay, same spiel I gave you yesterday. Once again, it's a lot of steps. Every step is a logical step, though. So that's why we give you the directions written out. We've got examples for you. If you have questions as we're going, let us know. Any questions right now about that first example? Okay, we're going to do one more, and then we're going to set you free. So, next one we've got 2x minus 3y equals 2. X plus 2y equals 15. Who is easiest to solve for? X in the second. So I'm going to put a little note to myself. X in number 2. I'm not even going to write the word solve for, because I'm being lazy. Okay, so we're going to take that second equation. X plus 2y equals 15. How do I get my x by itself? Minus 2y, subtract 2y. Yep, awesome. And x equals 15 minus 2y. It is not 13y. Okay. The reason why I like to go back and cross out the equation that I just rearranged is so I remember I'm not plugging back into it. Because if you plug this back into this equation, you're going to put yourself in an infinite loop of infinite solutions because you're plugging one equation back into itself. So we can plug this x in to the other equation. So we've got the x equals 15 minus 2y. That gets plugged in for x in the other equation. The other one. Okay. So that'll be 2 times 15 minus 2y. And then minus 3y equals 2. And we can distribute, combine like terms, and solve. Help me remember at the end of this problem, the all the way end, that we want to check this one. 2 times 15 is 30. 2 times negative 2y is negative 4y. It's minus 3y equals 2. Okay. We can combine together the negative 4y minus 3y. A negative plus a negative is still negative. So we've got 30 minus 7y now equals 2. And then you can freak out like I did yesterday that this isn't going to divide out neatly. But then you can remember you need to subtract 30, not add 30. So if we subtract 30, we have negative 7y equals 2 minus 30 is negative 28. I printed 140 copies of this, and I was like, this doesn't work. And then I figured out it does. Okay, and then divide both sides by negative 7. I get y equals positive 4. Hey, any questions right now? Hey, so we are going to take that 4, we're going to plug it in for x. So we've got x equals 15 minus 2y. Well, we're plugging in 4y to solve for x. That was a poorly worded sentence. So we've got that x equals 15 minus 2y. We're going to be plugging in the 4 for y, because we now know y equals 4. We've got x equals 15 minus 2 times 4. Two times 4 is 8. So now I've got x equals 15 minus 8. And 15 minus 8 is 7. So we get x equals 7. Okay. What would our answer be as an ordered pair? 7, 4. X always has to go first. So our answer as an ordered pair is 7, 4. Go ahead and glue in your notes and then freeze, because I want to show you how to check this. So I'm going to give you 45 seconds to glue. Glue expeditiously, please. Yeah. Yep. 6. 6 and an answer bank. Alright. See a few more people gluing, and then I want you guys to look up because I want to show you how to check this. I should have had you check it first because now there's like an awkward minute-long pause in the video. Sorry, video. Hope you're still watching. Whoever needs to watch it, whoever was gone. Okay, so we are able to check our solutions to any of these problems. The solution to a system of equations has to make both equations true. So I've got 7 and 4 as my x and y. If I were to come up here, I would need to look at my two original equations. Go all the way back to your originals. I'm going to do 2 times 7 minus 3 times 4. Is that what it was? 7, 4? Make sure I get 2. And then this one would be 7 plus 2 times 4. Make sure I get 15. So you can plug in x and y, and you could check both of your equations. All right, now I'll stop talking.